Welcome back. One question. Which of these maps would you prefer? This one or this one? Adding geographical context to your spatial data is extremely helpful. You can add streets, rivers, buildings, and more. Today we're going to learn how to add them to complement your thematic maps. Let's start. So to start with the lesson, you can pause this video and read carefully through the learning objectives of today. We're going to start with physical features. Physical features includes roads, buildings, and rivers. We can plot them by using the geomsf function, the same function that we used for doing choropleth maps and dot maps. And in this case, using specifically the color argument. For example, let's see how to plot physical feature with categorical data. As an example, we're going to map the road network in South America and color them according to their type. Okay, so let's see how to solve this. We're going to read the South Am road file and let's check the content of this file. So we need to identify the type of road network, and this type could be included in the type variable. As if we recall how to use the geomsf function, first we need to use ggplot to specify our data frame to the data object, and then use the geomsf function. So just to visualize the physical features only, we can use the geomsf function and identify what type of shape we are visualizing. In this case, we're looking to the roads, and then we can specify inside the mapping argument the aesthetic function using the color argument to visualize all of these roads by their type. Okay, so now we can see the South American roads uncolored by their type according to roads, to major highways, or to ferry routes. So now let's practice. Read that statement specified in this practice question and make your first physical feature map. Okay, so now let's see examples with quantitative data. For this, we can say that we can use quantitative data from physical features in environmental epidemiology. For example, we can visualize the concentration of chemicals or pollutants in wastewater surveillance. And in ecology, we can visualize richness estimations. We're going to use as an example, the classification of rivers in the Sacramento Basin in California, United States. For this, we're going to read the Sacramento Rivers dataset, and we can inspect the object to identify what is the name of the variable that contains that richness information. And here we have a richness estimate. So let's use the richness variable to visualize it. First, we need to identify what we're going to label by the quantitative variable, and now we can use the mapping argument and the aesthetic function to specify the color argument, the richness variable, and identify how the Sacramento rivers vary across their distribution by the richness estimate that goes between 2 and 7. Richness is the estimated number of fish species in each segment of the river. Okay, so let's practice a quantitative data physical feature map. For this, stop the video and read through the instructions. Okay, so how to use physical feature maps? We can use it to plot trajectory data and road network data, for example. As an example of trajectory data, we can evaluate the effects of human movement patterns in infectious diseases transmissions like dengue and malaria, which you can see referential papers highlighted in this as links. In this figure, you can see how human mobility data from GPS tracks was associated with dengue infection, while in the plot of the right, you can see how road network data is used to evaluate the interventions against malaria in Kenya. Both of them are depicted in a map using lines. So let's recap what we know until now. We know that each thematic map has its respective type of geometry. That there are three main geometry types: points, lines, and polygons. If we remember, in the previous lesson, we identified that dot maps are related with the point geometries and that choropleth maps are related with polygons. Now we add a third type of geometry that is called lines, that is used for physical feature maps. Okay, so now let's talk about multiple layer maps. Most of the maps need geographic context, as we saw in the introduction. And plotting multiple geometries require to overlap layers within ggplot. In that way, we're able to complement thematic maps with physical features. So how can we plot them? As an example, we're going to complement a choropleth map from the African countries colored by population with the African Transcontinental Highway Network lines using the AfriHighway dataset. Okay, so let's run this chunk to identify how to use it. So to solve this problem, we're going to fill it with the information required. So we're going to use the Afri countries dataset, and we're going to use the mapping argument to specify the static function and color and fill each of the countries with the pop_est variable. And then we're going to use the AfriHighway dataset to overlap the Transcontinental Highway Network. And now we can see the output. We overlapped a new physical feature over the choropleth that we already made. So here, the physical feature called AfriHighway is above all the other layers. But it can also be below. And we can complement a dot map from the AfriCapitals dataset with the AfriHighway layer. So in this example, we can see how we can interchange the overlapping according to the needs of the figure. First, we're going to add the AfriHighway object, and then we're going to use the AfriCapitals dataset that is going to be that's going to contain dots with size proportional to their population and also colored proportional to their population values. So in this way, we have below the map the free highway dataset, and over the highways you're going to visualize the dots in size and color proportional to the population variables of each capital. This is how you plot another map layer into another map. So let's recap about this. ggplot2 allows us to overlap multiple layers of map and to complement in that way thematic maps. For this, you need a local specification of data. So instead of specifying the data within the ggplot function, now we need to use different layers of geom_sf functions, and in each of them you will specify your data object. First, you're going to specify the data that you want to be below the other layers. The order of the layers, either below or above, will depend on the aim. Now it's your turn to create a multiple layer ggplot using spatial data. So read instructions and solve the problem. So how can we use multiple layers with physical features? We can use it in a scenario similar to Jon Snow map. This map depicted the locations of deaths in the 1854 London cholera outbreak. Those locations were complemented with a physical feature map that included the street roads of the city. And here we see the figure that we saw at the introduction, where we have just the dot map with the location of deaths in the outbreak, and in the right we have the same data with the street roads that help the viewer to localize where are the cases located in the space. So in figure 3b, the physical feature is below the dot map. This is why it looks much more readable. Okay, so to wrap up, we learned in this lesson how to represent physical features like rivers and streets, and how we can use them to complement thematic maps like choropleth maps or dot maps in multiple layers. As a summary concept map, we now know that we can complement thematic maps like choropleth maps and dot maps with physical features. And physical features visualize line geometry types. And physical features require to use geom_sf function in multiple layers. However, you probably may require to be more explicit with the background. To solve this, in the following lessons, we're going to see how to add base maps with Google Map-like backgrounds. So hopefully now you feel more comfortable visualizing physical features and using spatial data in multiple layers within ggplot. So see you in the next lesson.
For more resources, visit our website, where you can track your progress, access interactive quizzes and lesson notes, and connect with our teachers and other learners like you. And if you'd like a more guided experience, we also offer live online bootcamps with expert help. So join us at thegraphcourses.org to start your learning journey today.